Hello everyone. Uh, this is the repo for Team A's submission for the AlgoLYNX Hackathon. We submitted three different notebooks. The first notebook talks about how you can download the data from OpenEuro. The second notebook talks about our pre-processing that we took before using the classification. And in the third notebook, we talk about how we built a random forest classifier for the eyes open, eyes closed task using sklearn. These were the three notebooks that we submitted. Uh, but after the competition has ended, or hackathon has ended, we have done two more models, EEG Inception as well as ChronoNet. This was done after the event was completed. But if you're interested, you can also take a look. But in this particular demo, I'll be going through the pre-processing notebook as well as the two label classification using random forest classifier. So for the pre-processing, mostly we used M&E. We solely depended on M&E. These are the different pre-processing steps that we took. We filtered the signals between the desired hertz. We resampled the signal from acquisition frequency to the desired frequency. We also used ICA to remove ECG, EOG related artifacts. And then we also break the continuous signal into epochs using the fixed length epochs. In total, we had four different approaches for the pre-processing. Although there are four, we mostly depended on two. Um, Approach 1 and 2 are very similar. We filter the data between 1 to 40 hertz. We sample from 50 hertz to 100 hertz, and then we remove artifacts based on ICA, and then break the continuous data into 6 50 seconds samples. So in approach 1, for each sample, we will get six samples. Approach 2 is same as approach 1, except in the last step, we average across the 6 samples to get 1 50 seconds sample. Approach 3 and approach 4 are the same, except we filter the data between 1 to 20 hertz. um, this is how the code looks like. We load the raw data, we resample and filter, we extensiate ICA using 20 different components, and then we fit the data, we identify the bad components, and then we apply and remove the bad components. And the last step is to make fixed length epochs uh, at every 50 seconds. From here, we save the data as two different approaches. In approach 1, of course, we saved as it is. In this case, we would have gotten 6 different samples. So the data shape would be 6 by 61 by 5000. So 6 because we are breaking it into 6 different 50 seconds sample, 61 because of 61 channels, and 5000 because of we're breaking every 50 seconds. In the For the second approach is the same as previously, except we average across the 6 different samples. So in this case, our data shape will be uh, 61 by 5000. That's approach 1 and 2. 3 and 4 is the same thing, except now we are filtering between 1 and 20 hertz, right? Once that is prepared, we also went ahead and prepared the normalization. Here we are using standard scalar. Um, for this, we have decided that we will be using subjects 51 to 60 as the valid set. Hence, we loaded all the train set. We chose 50% of the data, and then we fit the standard scalar to to get the standard scalar sklearn object. The reason why we are using only 50% of the data is because loading all the data sometimes results in RAM issues. Since most of us are working on Colab, that is the only reason. If RAM allows, I think we can go ahead and load all the data. Once these two are done, that's our pre-processing step. From here, we can do different classification that's required. Uh, In this, we are building eyes open, eyes closed classifier using random forest classifier. We have three different methods. In method one, we select only the following channels from the 61 channels that exist, and we also use data from approach 2. Mm, so we're using these channels. These channels are related to occipital channels. In method 2, we only use the OZ channel. In method 3, we are using all these channels that was used in method 1 and P3 and P4. So in code, we have built a data frame just for convenience, which contains the file name where the different files are stored and their corresponding label, and whether to use them as in the training set or valid set. From there, we load the data, both the training the training F, which stands for training features, valid features. We load them. We make we we make the corresponding labels, 0 for eyes closed and 1 for eyes open, and we stack them up and then feed the random forest. And when we try the prediction on the valid set, we get a accuracy of around 72.4%. You know, the confusion matrix would look something like this. For eyes closed, it correctly predicts 23 out of 29, while for the eyes open, it correctly predicts 19 out of 29. In method 2 is the same thing, except as you can see here, only includes channel 29, which corresponds to OZ channel. Same thing, uh, the accuracy is slightly improved, but when we run it many times, it's almost same as method 1. And as you can see here, the confusion matrix also very similar to method 1. In method 3 was same as method 1 plus P3 and P4, um, and the process is the same. um, and yeah, the accuracy also very similar to uh, method 1 and method 2. That concludes our walkthrough. We have EEG inception as well as chrononet as well. We have added that to our repo. Um, Both of them give accuracy in the range of 80 to 89%. They are all based on deep learning methods. So please do take a look at them as well. Thank you.